I have a dream. A dream where all the APIs of my company can easily be provided to selected partners in a platform that is easy to work with. During the next 50 minutes, I will talk about our journey towards this dream. The journey begins when a partner wanted to improve the functionality of the app that they use for cars. They wanted to check if the car was insured in if, and if it was insured, it would display the details of the car insurance, like what was covered, what was the cost, and so on. If it wasn't insured, then the app would display the price for a new car insurance for that car and for that user, and make it possible to select different kinds of the insurances. And then make it possible to purchase that insurance within the app. This app had a lot of users, hundreds of thousands. So it would be a big business opportunity for if this functionality was implemented. When I heard about these plans, I thought to myself, this doesn't sound so hard. I had experience from building an API portal at the previous job. Unfortunately, that portal took a long time to implement. And then, when it was done, it took a long time or much work maintaining it. So I thought that the biggest challenge would be to find a way to build a portal fast and then make it easy to maintain. But my boss, he had higher dreams than this. He came to us in our team and explained that he decided that we would build a platform where multiple teams could provide their APIs to selected partners. This would be a huge business opportunity for if, because it would allow us to create integrations faster and with less effort than we did before. We could reach more partners and therefore more customers with our services, and in the end, make more money. We could create integrations with smaller partners that was not interesting before, when we had to create custom, expensive integration with every partner. On my team, we had a security guy. He was responsible for the security of the platform. He was the one that was going to put his stamp, this is secure. His biggest fear was that the platform would introduce a security flaw, something that could make like hackers get secure, like secret information about our customers that we didn't want to expose. Or maybe that the API stopped working suddenly. Or maybe that hackers could like make lots of calls to our services so that they stopped working for everyone, our internal users and the external ones. But we also had a girl on my team. She was an API developer. She takes joy in providing new services and new APIs. She doesn't like complicated processes or tools. She wants to do things fast and so that she can focus on her main focus, like getting things done. So it seems like this was a really important task, a huge business opportunity for if, but it also seemed very difficult. The requirements of security on one hand and easy to use seems to contradict each other when building a platform like this. So I couldn't really I didn't see a solution to this complex problem, but I started to look at a solution to this small problem of providing an API portal for the car application. after a lot of searching online, we decided that we wanted to use a service from Azure called API Management, because we thought it provided us with a lot of functionality that we could use. So Azure API Management is a service that allows you to kind of register your APIs and make them accessible to the different users of your portal. So that we could use the user management part so that we didn't have to manage the users ourselves, but let the portal handle that responsibility. And it could also manage the kind of access rights. So if we wanted to kind of hide a specific API, we could say that only the members of this group can see this API, so that we didn't have to think about that ourselves. We could use policy management to introduce logic on top of the normal API. This could be stuff like caching, mock data, or more or less any logic that you can think of. We can run this logic in for every, or for a specific operation, for every API, or for a specific API, or for all APIs at the same time, and also for a specific product that I will talk about later. So this made it really flexible, meaning that you didn't have to write, if you wanted to add functionality, you didn't have to write a new API for that you connected to the previous API. You could just add that functionality to in API management. It's a choice, so you can decide to use it as you want. We can use the portal that contains up-to-date information about the different APIs. And in there, you can also try the different APIs. It's really easy to make calls and see what happens when you call the API with a certain input. And we could monitor the performance and the errors of the API management and see which APIs have problems, where we have errors, who is failing to provide us with the correct subscription keys and stuff like that. And with the help of application insights, we can create reports based on the logs and send alarms when something went wrong. So now I will show you how to set up an API using API management. I will use my coding glasses. So I have created an API management service in Azure Portal. I call it Svetug API-M. And our API developer, she gave me, thank you. My API developer, she gave me a file with an open API specification. So this is kind of a contract that describes what are the inputs and outputs and examples of the API. Still not there, right? Now, and she doesn't like to write things by herself, so she added a package, a NuGet package called Swashbuckle to her .NET project. It also works with .NET Core, and that generated an open API specification for her project, so she didn't have to write all this herself. So she gave it to me, and I will try to add that to this portal. So I will click APIs. And so now this is how you add a new API. So I have this specification. It used to be called Swagger definition. So if you heard someone talk about Swagger, it's the same thing as Open API. But if you have some other kind of definition file, or if you have a logic app, an API app, or a function app, then you can add those pretty easily as well. Or you can start with a blank API and kind of write the stuff yourself. But since I have the Open API specification, I will select it here like this. And I will write the description. Here you can buy car insurance. We will do HTTPS and we will add a suffix called buy insurance. We will add it to the product car insurances. So a product is the way to like package your APIs. So this is the way you cannot subscribe directly to an API. You subscribe to a product, and that way you will get access to the APIs inside of that product. I will add versioning. I will choose the standard path, meaning that we will write version 1 in the URL. We can see the kind of example URL here. This is the name of our API manager, and then we have buy insurance and then version 1. So this is kind of neat. If you want to, you can use put the versioning in the header or query string. So I will press create here. And bam, there it is. We have the buy insurance, version 1, and we have 3 operations. Start calculation is like the first call you make to get a price. If you want to change something to like from full insurance to traffic insurance or something like that, maybe you would like to add some extra parts, then you can change it and call the recalculate price to get the new updated price. Purchase insurance is when you want to purchase your insurance. So this seems pretty fast, right? So I will like to test it. So we can test it here in the Azure portal or in the publisher or developer portal. So we will try it here first to see that everything works. So the Azure portal is of course only meant for the developers of the API, and the developer portal can be used by the developers from external companies. So we are in the start calculation operation. We can specify what kind of content type and subscription key that we're going to use. And here we can see an example of a request to this operation. So we send in the registration number, social security number, and yeah, that's about the most important stuff. So we can press send. So this goes to the test backend. So it could take a few seconds the first time we do this. Yes. Soon it will return. Eventually. So this is actually not a problem with API management. It is the backend that is this slow in responding. So you cannot blame it on this service. Okay. So there was no response. So let's try again and see if it's better this time. This makes, yeah, okay, so here it was. I was about to add mock data to the response. But now I didn't have to do that, so we eventually we got a response from this API, and this is the correct response. We have some information about the user, we have some stuff, and we have the coverages, which is kind of the different stuff that is included in the insurance. So we have some prices here. So this is what we need to make the application that should display information about the car, the price of the car insurance. So that's great. So let's look at the developer portal. This is the standard layout of the developer portal. So you can modify that. I think, yeah, I will show you later how we made the changes as at if. So I can press APIs and then version 1. And then kind of same thing. It will display the documentation. So this is, let's go to the start calculation because that is slightly more simple. This is a sample request in application JSON, and it can return 200. Okay, and when it does, start here, it will turn something like this. And if you want to learn more specific about the customer, you can press here. You will have the sample and the schema, kind of what is the contract for this particular part of the response. So quite complex. Quite complex response. And we can, same thing as in the Azure portal, we can make a request to try it out. Now it was faster, we got the same response as before. So we can see that adding it was pretty fast, and if you imagine that I was a developer wanting to learn more about this API, it was really fast from the point that I looked at the page until I could do my first API call. So the next thing, I guess, is to implement this call into my application. So I wanted to show you a little bit about what's available in this API management. So first we will look at the groups. I told you that, okay, I created a car insurance group that is supposed to be like the members that are wanted to see this API. They must be a member of that group. And I also specify that our API should be part of the car insurance's product. And here you can see that for access control, it is visible for the car insurance group that we looked at before, and also administrators. So right now I'm administrator of the platform, so I can always see this. If you guys register, then you will be a part of the developer group, which we can add, but we can also keep it kind of secret like this. So it's up to you guys to decide how much visibility do you want for your specific APIs. Do you want to lots of users? Do you want to kind of select who gets access to your APIs? In our real API management instance, we have a connection to our Azure Active Directory. So then it's pretty easy to add a group, for instance, with like all if employees involved in IT. So in this way, we could expose the car insurance product to all if employees, more or less. So if you have that already, then it's a quite easy way to administrate at least the users of your company. For external companies, you will have to add it to the car insurance group. So by default, now look at the different identity providers. By default, the users have to register with a username and password. So kind of create a user for your specific API management instance, which is okay, but it's also possible to add many different identity providers. So here you can have Facebook, Google, Microsoft, Twitter, and if your favorite identity provider is not here, then you can add it in the OAuth 2 tab or in the OpenID Connect tab. So it's pretty extensible, meaning that people doesn't have to create a user and remember the password for your specific API management instance. They could log in with your Microsoft account, Twitter account, or Facebook account. Whatever you decide. Maybe you don't want Facebook for your business users, for instance. But it's totally up to you to decide. It's pretty easy to do whatever you decide. So then what about the costs? We can go to scale and pricing. So look at this. So there's a developer kind of tier that we use for all our environments except for production, because it contains all the features that we could need, meaning Azure Active Directory integration and virtual network support. But the thing is that it doesn't contain a service level agreement, so we don't like to put our production stuff into this because it's not as supported as the rest of the alternatives. So, and then they are, so this costs 420 crowns, Swedish crowns a month. If you want like production-ish level support, you must go to some of the other stuff. So if you want no Azure Active Directory and no virtual network, then you can go with the basic. So 1,300 Swedish crowns per month. If you want Azure Active Directory, then you can go with standard. And if you also want a virtual network, then you must go with premium. So now it gets kind of expensive. Or you can go with the consumption-based plan, meaning that you kind of pay as you go. I didn't really experiment much with this, but so it's quite a new offering. So this is what it costs, but I mean, go with developer for everything except your production stuff is my advice. Okay, so let's go back to PowerPoint. So it seems that Azure API Management can be used to expose at least one API to your selected partner. And it's quite easy to use for both like the API developer and the partner that is using this API. So I realized I was finished with the first task of providing one API for the car application. But I thought to myself, is this solution good enough for the second task where we wanted to create a platform where multiple teams could expose their APIs to multiple partners in kind of an enterprise environment-ish? Now the security guy complained and said that this was not a good solution at all. First of all, he said, we are working in multiple environments, meaning that we work in integration tests, system tests, acceptance tests, and production. So there must be a way to kind of copy the configuration between the different environments so that we don't have to go into the portal and manually do the test because do the configuration changes, because this could be really error prone. And like, what if you forget to do a change, and that could cause a big change when you end up in production. And they also said that there must be a way to kind of limit what the API developer can do, so that she doesn't change something that looks good, but then it has a catastrophic effect. So it could be that the API stops working or exposes a security vulnerability. So this was not good enough. So the problem we wanted to solve can be described as this. Imagine that we have two environments. To make it simple, we have a test environment and we have a production environment. Each environment contains an API management instance and a backend with the API server. And imagine that we make a change to the test environment, and now we want to copy that to the production environment. But we don't want to go into the Azure portal making the change. Because what if we forget to do something? So with this arrow, we want to copy the stuff. But actually, this is not something that is supported by Microsoft. What you get is kind of what you see in the portal. There are no connection between the different API management instances. So we must find another way to solve this that is not supported by Microsoft. After a bit of searching, we found a GitHub page written by a guy from Microsoft that explained how to solve these two issues with multiple environments and the control of the configuration. So the solution was to create Azure Resource Manager templates, or ARM templates for short, of the configuration, and then put those templates into source control. So now we will have pretty good control of what we deploy to Azure. So the first time you deploy your ARM template to Azure, it will create all the services that are described in the ARM template. So ARM templates are a way to describe the infrastructure of your services in code in the form of JSON. That is why it says JSON in the ARM there. And the second time you deploy, if you change your ARM template and then deploy it to Azure, then Azure will figure out to do only the changes that you made and keep the stuff that is not changed the same as it was before. So we can put the configuration of our API management instance. Maybe we put the API that we added and the rest of the configuration, the groups and products and so on. And now we can deploy that to production. But now the API developer was jumping up and down and saying that this is not a good solution for her. Because if she wanted to create a new API, or if she wanted to make changes to it, then the only way for her was to manually edit the ARM templates, and they're not that easy to read and work with if you're doing everything by yourself. So she would prefer if there was a way to kind of work in the portal as I did before and make the changes and try them out and see if they work for her or not. And when she was happy, she would like to find a way to kind of generate the ARM templates based on her configuration, and then put those templates into source control, and they can be deployed to production. So this was hard, I thought, but actually on the same page where I found the example from Microsoft on how to put the ARM template configuration for API management, there was a tool that promised that they would generate ARM templates based on the Azure API Management instance. So this was exactly the tool that I was looking for, kind of a silver bullet thing that would solve all my problems. So now I had a good kind of workflow that seems like it would be easy to use for the API developer, because she could try out and work in the API portal, and we will have control because we have the changes in source control in the form of ARM templates. So everything was great, I thought, until I realized that this tool was promised by Microsoft. I think this was in June. It didn't really exist. So a bit sad, I started to look for another way around this problem. So I found another GitHub page, not the same one, but this contained a tool that actually created an ARM template, a huge ARM template, with the configuration of an API management instance. So this was not exactly what I needed or I wanted, because I wanted the many small templates that would be easy to work with, and when we're doing merges and see what changed and not. If two people are kind of making changes to huge ARM templates, then it's harder to see what changed and kind of map the change you made to the changes in the big ARM template. So I decided that I would try to improve this tool so it would create the many ARM templates that I needed. So, and I also realized that this tool, it wasn't really complete because it didn't include all the settings that we needed for our use. So I had to add those missing features to the original ARM template and kind of transform the output of the original template into small ARM templates. But after many weeks of hard work, I was finally done. Yay, I was happy. And to make sure that everyone could benefit from my work, I put those changes into GitHub so that you don't have to write this same program yourself. And I made pull requests to the original tool. But now, again, the security guy objected, saying that this was not a good solution at all because he didn't have control of the configuration. I mean, the API developer could make a change that was totally insecure in the portal, and then generate the ARM templates, and then deploy that change to production, and everything would blow up, maybe. So he wanted more control than this. So I found another way to solve this. So the API developer would put her changes into her team branch, and then she would make a pull request into the main branch, and the security guy would approve this pull request. And when that was done, the changes would be deployed to the Azure production or another environment. Of course, we start with system test, and then maybe acceptance test, and then finally production, so that we can use those ARM templates to maybe deploy the same templates but with different parameters to respect the different changes in the different environments. But now the API developer said again that this is a bad solution because this was super slow. What if she needed to make a typo in her and correct a spelling mistake in her API, or make a really small change in her API that didn't affect anyone else? Then she would have to wait for approval by the security guy. And that would cause a frustration for her and a lot more work for the security guy that would have to approve like even the smallest changes. So I made it possible for the API developer to do team branch deploys based on the configuration of her API. Or in this case, what that we had before, that the API developer would be able to make changes to the purchase insurance API, but not other APIs. But now the security guy objected again, saying that what if you wrote some big change in a team branch and then tried to deploy that with the team branch deploy? So I thought about the security of the two deploys. So I made that the team branch deploy would have less access rights, so that it only could deploy the stuff that was related to her API. And if she wanted to make a change that involved changing something that could affect other APIs, then she would have to do a pull request, as I described before. So this is done by something called role-based access security and using security principles. So you can Google that if you want to learn more about those things. But it seems like we found a way that was both fast for the API developer and secure. So it was fast for the API developer when she wanted to change stuff in her API, and it was secure when she wanted to change stuff that could potentially affect other APIs or the whole platform. So now I would like to show you how to use the ARM tool that I mentioned, that I extended. So before I begin, I will show you, this is the GitHub page. So the name of the tool is API Management ARM Template Creator. Pretty long name, and I didn't invent it, but it kind of describes what it does. So it's you're calling it by PowerShell, and this is the kind of usage of the original tool. And this is how you use it with my tool. So you can see that my tool actually takes the input, the big ARM template, and then kind of splits it up and writes those many small ARM templates to disk. So I won't go into the details, but you can find this on my GitHub page. So what happened was that first we will run the tool just to be sure that we have, well, we added the API, right? So now I run the tool, create set of templates, and you can see here that 9 files have been changed. So we can look at, so it seems to create a directory called API/by insurance. So we get a directory for this API. So we get 1, 2, 3 files in the kind of root directory of that. And then we get 1 file in the version 1 of that API. And we also get a product called car insurances. And there's some small changes in those files as well. So when you add something new, then you get quite a lot of new files. So we will not look into detail of those. We'll stage those changes and kind of focus on what will happen with ARM templates when we make a change. So what the security guy and the API developer realized was that this API was actually created for the web shop. So it contains some stuff in the JSON response that is not really needed for the API users. So we want to remove that, kind of transform the output before we send it. As I mentioned before, with the policies, this is possible to do without adding another kind of service or something. So we will go to, so we can see. I will just tell you what I'm. Lot of stuff. So this is the stuff that are related to the web shop. So we have, for instance, the UI content that is used by the web shop, but we don't really want to send it back to the customer, and we don't want to kind of ask the API developer to create a new API just for us. So we want to transform this response before we return it. So we will go to APIs, by insurance, and then we'll click on Start Calculation. So here, this is kind of a view of the policies that you can add to, in this case, Start Calculation. So if you wanted to, you could click here, or you can click add policy, and then you get a kind of a list of the policies that have kind of a nice user interface. Or if it's not listed there, then these are the policies that are available, but there's not such a nice user interface. Or if what you want to do is not listed here either, then you can write your own policy by writing C#. So this is what we will do. I will go to transform JSON. So it's basically kind of an if statement here. If the response from the backend is 200, meaning OK, then we will get the response as JSON, and we will remove the keys in the response that is UI content bank list USB anti-theft message. And then, remove them, and then return the transformed JSON. So I will copy that. I will input this into the correct place. So inbound is the transformation that you want to make with the request before sending it to the backend. And backend is like the changes that you want to make before you send it to the backend. And outbound is how you want to transform it before you send it to the caller, the response. So this is what we want to do in this case. So I will add the code here. And if we wanted to add something for error handling, then we could add it here on error. So let's try that. So we got the response. And we'll see if we were successful. It seemed like we actually removed the stuff that we didn't want to display. So it seems like this is a change that we would like to put into the production environment, or at least check into source control. So we could think that this Azure API Management is our test environment. So we generate the ARM templates based on that and put them into source control, and then later we can deploy those into other environments. So I will run my template again, or my PowerShell command. So let's see what changes we got. We got a change to this okay, so we got, this is not so important. Okay, so it's a bit hard to read now. But the important thing is that now we have the policy. So here you can see the policy that we added. We didn't have a policy before, so therefore we didn't have a file. So this file is new. And so it's this kind of the ARM template for the version 1 by insurance now contains a link to the new policy. So instead of, you can almost see there's a link to the web shop initpolicy.xml. So we are, instead of putting everything into one big ARM template, we are having links to the different policies and also other ARM templates. So the this seems like a pretty good way, I think, to. So now we can just stage those changes and then right, doing cool stuff, and then push that, and then if it was like a change just for the API, then we can do a team deploy. Or if it was a change to the other stuff that could potentially break for other people, then we would have to make a pull request to the main branch, and the security guy would have to approve this change, and then he will deploy that to the selected environment. So I will go back to PowerPoint and ask you, what questions do you have? Yes. Yes, the idea is that we will have, if it's quite a huge company, so I think we have 1,000 people working with IT in different countries. So to have kind of one platform for all APIs. So, yeah. It's a good question, and I thought about that. So one way is to have like each team get their own kind of test environment, as we have the Svetug API M. Or also you could, when you generate the templates, you can say that, okay, I want to generate the template for the buy insurance API. So I'm not interested in whatever the other team is doing. But so it's up to everyone to decide what is their workflow, basically. So some other questions? So I thought about security. So I mean, the security guy, he wants this solution to be secure. So there is a possibility to add a security mechanism called Web Application Firewall in front of the API management instance, so that we can kind of make sure that everything is secure, and we don't have to secure every single API. So, do you share my dream of providing the APIs of your company with selected providers? Do you want to make it easier and faster to provide your services to developers inside and outside of your company? Then you can do 3 things. You can Google for Azure API Management to learn more about this service and what it can do for you. You can visit my GitHub page, which I'm Nils Hedström, and learn more about this tool that I extended, and if it's something that you can benefit from. And you can send me an email. I work for IF, and my name is nils.hedström. Or you can ask me questions after the presentation. Thank you for listening, and good luck with your API challenges.